The F-16 Fighting Falcon, renowned for its agility, versatility, and power, is a key asset in modern air combat and support operations. Witnessing an F-16 takeoff at full throttle is both a technological marvel and a display of raw power, demonstrating the aircraft's readiness to respond to missions of varying intensities. This video covers the key stages, technology, and tactical importance behind the full-throttle takeoff of the F-16, detailing the mission preparation, takeoff process, and the significance of the F-16's role in diverse combat scenarios. Mission preparation ready for takeoff. Before an F-16 can take off, extensive preparations are required to ensure it is fully mission ready. Ground crews, engineers, and pilots work in tandem to inspect the aircraft. Technicians meticulously examine the F-16's airframe, engine, avionics, and weapon systems to confirm everything is operational. This includes checking the Pratt & Whitney F-100 or General Electric F-110 engines that propel the jet, ensuring they are capable of delivering maximum thrust for rapid takeoff. Armament loadout. Depending on the mission, be it air superiority, ground attack, or reconnaissance, the F-16 is loaded with specific weapons, from AIM-9 Sidewinder missiles for air combat to AGM-65 Maverick missiles for ground targets. Fueling for distance. The F-16's internal fuel tanks are topped up, with optional external tanks added if the mission requires extended range or more loiter time over a target. The pilot also performs a thorough pre-flight check, calibrating systems and confirming that all navigation, targeting, and communication equipment is set to optimal conditions for the upcoming mission. Taxiing to the runway from hangar to takeoff position. Once the F-16 is cleared for takeoff, the pilot initiates the taxiing process. Slowly maneuvering to the designated runway, the F-16 moves across the airbase under the guidance of the ground crew during this phase. System diagnostics are conducted to ensure everything from hydraulics to targeting systems is functional. Clearance communication is maintained with the Air Traffic Control ATC tower, ensuring the runway is cleared for a full-throttle takeoff. The powerful afterburner engine is essential in the F-16's full-throttle takeoff, providing thrust up to 9 times the force of gravity 9G and enabling the aircraft to reach speeds over 500 knots during initial ascent. Takeoff. Full throttle to the skies. With everything checked, the F-16 lines up on the runway and the pilot throttles up. The afterburner is engaged, igniting a secondary fuel stream and creating a visible and intense exhaust plume. This surge propels the F-16 rapidly forward with the following steps. Acceleration. As the F-16 accelerates, it reaches takeoff speed within seconds. With its aerodynamically designed wings and lightweight airframe, the F-16 achieves liftoff quickly, usually within 2,000 feet of runway. Vertical climb. The pilot may initiate a steep, rapid climb right after takeoff. In a combat scenario, this minimizes the aircraft's exposure to ground threats while quickly reaching operational altitude. Supersonic transition. The F-16 can transition to supersonic speeds as it ascends, allowing it to reach mission-critical areas quickly or intercept aerial threats. The sheer power of the F-16's afterburner takeoff not only saves time but also ensures the jet reaches high speeds and altitudes efficiently. En route maneuverability and mission execution. Once airborne, the F-16's adaptability becomes evident as it cruises towards the target zone. It can maneuver in complex flight patterns due to its high thrust-to-weight ratio and advanced flight control systems. During this phase, high-speed navigation. The F-16's radar and navigation systems guided accurately to the mission area, whether for reconnaissance, close air support, or intercept missions. Stealth evasion tactics. Using its agility, the F-16 can execute evasive maneuvers to avoid enemy radar and anti-air defenses. Weapons system activation. Depending on the mission, the pilot arms the F-16's onboard weapons, ready to engage targets immediately upon arrival in the designated operational zone. Significance of the F-16 full-throttle takeoff in combat missions. A full-throttle takeoff allows the F-16 to reach high speeds and altitudes in a matter of seconds. This is critical for rapid response to threats. Whether it's defending airspace, engaging enemy fighters, or performing a ground support mission, the F-16's quick takeoff allows it to be one of the first responders. Reduced vulnerability. The high acceleration and climb rate mean less time exposed on the runway and lower vulnerability to ground-based threats. Strategic agility. For missions requiring immediate presence, such as intercepting incoming threats or providing air support to ground troops, the F-16's powerful takeoff shortens response time, increasing mission success. The bombing run. Target acquisition and engagement. Upon reaching the target zone, the F-16 pilot shifts to a bombing posture, a phase that requires intense concentration, accuracy, and timing. Target lock-on. Using advanced targeting pods like the Sniper or Lantern low-altitude navigation and targeting infrared for night, the F-16 pilot acquires a lock on the target. These systems use infrared and laser technology to detect targets even in poor visibility, and the pilot can identify and confirm the target on the HUD. Precision bombing techniques. Depending on the mission, the pilot may use one of several bombing methods. Dive bombing. For higher precision, the pilot may position the aircraft into a controlled dive, allowing them to see the target in the HUD, confirm the approach angle, and release the bomb at an optimal range. Level bombing. For larger targets or less precise strikes, the pilot can release bombs from level flight at a higher altitude. With GPS-guided bombs, such as JDAMs, the pilot can lock onto coordinates and release from a safe distance. Laser-guided bombing. For precision strikes, the pilot can guide bombs using a laser designator, which ensures the bomb homes in on the designated point. This is particularly effective against fortified or moving targets. Bomb release. When ready, the pilot releases the bombs and quickly maneuvers away from the blast radius. The F-16's agility allows it to escape danger zones rapidly, reducing the risk of retaliation from anti-air defenses. Evading enemy defenses. Exiting the target area. After the bombs are released, the F-16 pilot immediately prepares for evasive action. Exiting the target area safely is a priority, as the aftermath of the bombing often prompts enemy response. Evasive maneuvers. The pilot performs sharp turns, climbs, and dives to evade potential anti-aircraft artillery or surface-to-air missiles. The F-16's agility and high thrust-to-weight ratio make it highly maneuverable, enabling quick changes in speed and direction. Electronic countermeasures. To prevent enemy tracking, the F-16 can deploy countermeasures like chaff for radar interference and flares to decoy heat-seeking missiles. High-speed egress. After clearing the target area, the pilot may switch to afterburners to reach a safe distance quickly, heading toward friendly territory or rallying points if the mission involves multiple aircraft. The careful exit strategy is crucial to ensuring mission success without compromising the safety of the pilot or the aircraft. F-16 bombing missions are a testament to the skill and precision required in modern aerial warfare. The pilot's journey from meticulous preparation to the high-stakes bombing run showcases the technical sophistication and strategic impact of the F-16 in combat. These missions demand not only the F-16's advanced avionics and weapon systems, but also the pilot's ability to navigate hostile environments, deliver precision strikes, and return safely to base. Through careful planning and execution, the F-16 and its pilots remain central to achieving air superiority and supporting ground forces on the battlefield.